Okay, Algebra 2 Trig, we're going to start 3.6 graphs of rational functions. We found horizontal and vertical asymptotes yesterday, and now we're actually going to go through the whole process of graphing. So our central question is, how do I graph rational functions? And here are the steps, or at least the guidelines of how to find rational functions. You can go ahead and write that down. Okay? And then I'm going to go over kind of the process of how you would find rational functions. So the first thing I want to do is I want to go ahead and just draw an xy axis. And then the next thing I want to do, I want to list all the critical elements of a rational function. So here are the critical elements. I want a y-intercept, if any. I want an x-intercept, any vertical asymptotes, holes, and horizontal asymptotes, and the last thing is just any additional points. And I'll go through how to find each one. Okay, so the first thing I want to do is I probably want to factor and see what I can cross out. Okay, so if I factored this rational function, it would be x times x plus 3 over x plus 3, x minus 2. And I've noticed that I can cross something out. I can cross out the x plus 3's. And whenever I can cross a factor out, this is where a hole is going to be. Okay, so my hole is going to be at the x value of negative 3. And right now my rational function is going to be x over x minus 2. I probably want to work with this rational function right here. Okay, so my hole is going to be at negative 3 because I crossed out x plus 3. And then I'll have to plug in negative 3 right here to find out what the y value is. So I'm going to do it off to the side. So it'll be y equals negative 3 over negative 3 minus 2. And that'll turn into, negative 3 over negative 5, which is 3 over 5. So my hole is going to be at 3 over 5, or negative 3 comma 3 over 5. Okay, so now I know I have a hole at negative 3. Now I'm going to look at this rational function that I've simplified. And you learned yesterday that whatever makes the denominator equal 0 is where the vertical asymptote is. So I know I have a vertical asymptote at x equals 2. And then let's go over horizontal asymptote. You can use either equation for your horizontal asymptote, but I'm going to use this one just because it seems easier. While n and m are both the same because they're to the first degree. So I learned that if it's the first degree, I'm going to take the leading coefficients. So it'll be 1 over 1. So I know I have a horizontal asymptote at y equals 1. Okay, with y-intercepts and x-intercepts, you remember the y-intercept is when x equals 0. So I'm going to do some work off to the side. So I know f of x equals x over x minus 2. So I want f of 0. Okay, because my y-intercept is when x equals 0. So my x is 0. So I'm going to plug in 0 over 0 minus 2. Which is 0 over negative 2, which ultimately is 0. So my y-intercept is going to be at 0, comma 0. Okay. My x-intercept is a little trickier. My x-intercept is when y is 0. So I know my y is my f of x. So if I make my f of x equal to 0, so 0 equals, and then the rational function's x over x minus 2. Well, 0 equals 0 over negative 2, which ultimately is 0. So my y-intercept is going to be at 0, comma 0. Okay. My x-intercept is a little trickier. My x-intercept is when y is 0. So I know my y is my f of x. So if I make my f of x equal to 0, so 0 equals, and then the rational function's x over x minus 2. Well, what I would do is I would multiply both sides by x minus 2 to solve for my x value. And I know these cross out. 0 times x minus 2 is 0. So again, x equals 0. So my y is 0 when x is 0. And coincidentally, my x-intercept is also my y-intercept. Okay? So let's graph everything we have here, and then we'll kind of decide what additional points we want. So I have a x-intercept and a y-intercept of 0, 0. I have a vertical asymptote at x equals 2. I have a hole at negative 3. Well, let's do the y horizontal asymptote first. The horizontal asymptote is at y equals 1. And I have a hole at negative 3, comma 3/5. So I know 3/5 is less than 1. It's about a little more than halfway up. So I'm going to draw a hole here. Okay? All right, so the additional points are going to be a table. I'm going to make a table, and I'm going to pick x and y values that will help me. Well, I know my rational function. If I look to the left of this graph, I know my graph always goes towards the asymptote. So since this point is lower than that one, I know it's going to go towards the left. It's going to go really close to asymptote, but never quite reach. And the only way this graph can finish is if it goes down towards the vertical asymptote, but again, it never reaches. Okay? So I know I have all my x values covered from here to here. I also need a graph to the right side of the vertical asymptote. So since this is 2, my additional points will probably be 3 and 4. I want to graph a couple just to see the behavior of the graph. Okay, so if I graph 3, I'm going to plug into this equation right here. So when x is 3, it'll be 3 over 3 minus 2. So 3 over 3 minus 2 is 3. Okay, when I plug in 4 into this equation, it'll be 4 over 4 minus 2. So 4 over 4 minus 2 is 4 over 2, which is 2. So here are my additional points. It's 3, 3, 3, 3, and then 4, 2. Okay, so looking at this, it looks like this one's higher than this one, so it's probably going to go down, and again, towards the horizontal asymptote, never quite reach. And then it's going to go up towards the vertical asymptote and never quite reach. And there's my rational function. Again, make sure all your x values are covered, and I have covered every x value. And if you have any questions, go ahead and write it down, and we'll go over it tomorrow. Have a good day.